Hello students, myself Amrita Roy. Today we are going to study about electric drives part 1. So first let us go through the contents. So we are going to study about what is electric drive, the block diagram of electric drive, advantages and disadvantages of electric drives, and factors governing selections of electric motors and applications of electric drives. So what is basically an electric drive? An electric drive is basically a system which is used to control the movement of an electrical machine. This drive employs a prime mover such as a petrol engine, otherwise diesel, steam turbines, otherwise gas electrical, and hydroelectric motors like a main source of energy. An electric drive can also be built with an electric drive motor as well as a complicated control system to control the motor's rotation shaft. Here is given the block diagram of an electric drive. So we see that we have a source, a power modulator, motor, load, sensing unit, control unit, and input command. So the source is basically feeding the power modulator. The power modulator is basically feeding the motor. The output of the motor is being controlled by a sensing unit, and the sensing unit is controlling a control unit. The output of the control unit is feeding the power modulator, and the input to the control unit is being obtained from an input command. So here these are the parts that is basically forming the the whole unit or the system of an electric drive. So what are the basic functions of each low block? We are going to study in details. So the power source. The power source in the above block diagram basically offers the necessary energy that is required for the system to run, and both the converter and the motor interfaces by the power source is to provide the changeable voltage, frequency, and current to the motor. That is basically from the source we are going to supply the voltage, current, and the power that is necessary to change the frequency or provide the frequency to provide the drive to run the system. Or if we need to change the frequency, we will obtain that by varying the frequency from the power source. Next one is the power modulator. The power modulator can basically be used to control the output of the supply. The power controlling of the motor can be done in such a way that the electrical motor sends out the speed torque feature which is necessary with the load. During the temporary operation, the extreme current will be drawn from the power source. That is, the power modulator can be basically used to control the output power of the supply. Now this power modulator is basically controlling the motor, that it will control the speed torque feature that will be necessary to operate the load. But during extreme conditions, the power modulator will not be in action and the direct excess current will be obtained from the source. Next one is the load. So the load is basically mechanical, and the mechanical load can also be decided by the environment of the industrial process, and the power source can be decided by an available source at the place. That is, the mechanical load can be decided by which type of industry, by the type of industry based on the environment, and the necessary power source can also be decided by the available source that is available at that particular place. Now we can also choose other electric components, namely electric motor, controller, and converter. So it is up to us whether we want to choose other electric components that is necessary for the system. Next one is the control unit. The control unit is mainly used to control the power modulator, and this modulator can operate at power levels as well as small voltage, and it also works the modulator as preferred. This unit also produces the rules for the safety of the motor as well as the power modulator. The input control signal also regulates the drive's working point from input to out to the control unit. So the control unit is basically used to control the power modulator, and this modulator can also operate at power levels as well as small voltage. So it has the capability to operate at power levels as well as small voltage levels, and it also works on the basis of the preference of the power modulator. So this unit will basically produce the rules that are safe for the motor as well as for the power modulator, and the input to this control signal or control unit will be obtained from the input command. Next is the sensing unit. The sensing unit in the block diagram is basically used to sense the particular drive factor such as speed, motor current. This unit is basically used for the operation of the closed loop protection. That is, the sensor or the sensing unit is used to sense particular drive factors that are necessary to drive the system, that is the speed, the motor current, and it is also used for the operation of closed loop protection. Next is the motor. The motor is indented for the specific application and can be chosen by believing the various features such as the price, reaching the level of the power, and the performance necessary by the load throughout the stable state as well as active operations. So the motor can be chosen on the basis of the specifications that is required for running the load, and it will also depend on the various features depending on the output or the industrial requirement, that is the price, the level of power performance necessary for the load, also the rated voltage and rated currents, and also on the performance of the motor, how it will work in the stable state. Next one is the advantages and disadvantages of electric drives. So the basic advantages are that these drives are obtainable with an extensive range of speeds, power, and torque. They also do not contaminate the atmosphere, and they have flexible managed characteristics due to utilization of electric braking. The disadvantages are that this drive cannot be used where power supply is not accessible. That is, if we do not have a source, the drive system is basically dead. The power breakdown also is totally stops the entire system. So in case if any of the block is stopped or is fall short of, or any of the block has a complete breakdown, the whole loop will be broken and the whole system will come to an end. Next, the dynamic response of this drive is poor, as many factors, as many blocks are included in this total system. So basically the efficiency or the output or the dynamic response is very poor in this drive system, because many commands or many blocks are involved in one single system, thus decreasing the performance or the dynamic response of the system. Next one is the factors that are governing the selection of electric motors. So the nature of electric supply. Whether the supply is AC or DC, that is single phase or three phase AC, or pure DC or rectified AC, can be utilized for the motor. Next one is the nature of the drive. Whether the motor is to drive an individual machine or a group of machines. The nature of the load. Whether the load requires a light or heavy starting torque, whether also the load torque increases with speed or remains constant, and also whether the load has heavy inertia which may require long starting time. Next one is the electrical characteristics of the motor. So the characteristics are starting characteristics, running characteristics, speed characteristics, that is the speed control, and the braking characteristics. It also will depend on the size and rating of the motor, whether the motor has overload capacity, the pull torque is sufficient enough or not. Next one is the mechanical considerations. So the type of enclosures, the type of bearings, the type of transmission of drive, the type of noise level, And lastly, it will depend on the economic condition, that is the cost, that is the capital cost and the running cost. Last one is the application of electric drives. So it has various applications for power generation. It has applications over wind turbines, tidal turbines, wave power and hydro. Next one, for changing material characteristics and shape, it has material processing, that is definite shape and indefinite shape. For precise mechanism, it is used for cutting tools, forming machines, sewing machines, paper machines, rolling tables and robots. And for indefinite shape applications, it has other mechanisms for mixers, centrifuges, extruders, autoclaves, crushers and mills. To control flow, pressure and position, that is for moving, dosing, pressure change, it has applications for three variety of states, that is for solid, liquid and gaseous. So for solid state, it has moving means, that is for moving cranes, roller and belt conveyors, lifts and excavators. For liquid, it has the following application: for pumps, that is for volume including piston, for dynamic including centrifugal. And for gaseous state, it has the following application: for fans and compressors. So for fans, it has fans, conditioners and compressors. And lastly, it has application for propulsion and transport, that is for marine propellers and cars. So we have successfully discussed the application of electric drives, the components of electric drives, their advantages and disadvantages, and the factors that are governing the selection of the particular motor required for running the drive. Thank you.